So in these notes, what we're going to look at is we're going to go over some problems where we are using area and looking at how we can apply these in real world situations. So you're not going to do the warm up on these notes. So we're going to start by looking at problems from that will be similar to the types of problems you'll see on your homework. So when you go to work on your homework, you'll want to, if you have questions or need to refer back to something, you'll want to look at how these problems were done, and they should help you complete most of your homework. So in this first example, it says it takes 65,000 solar cells, each 1.25 inches by 2.75 inches, to power the Helios prototype, shown at the right. We don't have that picture on here, but it just looks like a, if you ever have skateboarded, it kind of looks like a half pipe. How much surface area in square feet must be covered with the cells? The cells on Helios are 18% efficient. Suppose they were only 12% efficient, like solar cells used in homes. How much more surface area would need to be covered to deliver the same amount of power? So there's two questions here. The first one is, how much surface area in square feet must be covered with the cells? Okay, so what we're going to take a look at here is there are 65,000 solar cells. Each one is 1.25 inches by 2.75 inches. So in order to figure out how much surface area must be covered with the cells, we would need to go about figuring out the total surface area covered by the total number of cells. So if we look at this, we have 1.25 inches by 2.75 inches for each one. So this is a rectangular shape, and so this would be a total of, if we want to find the area, so area of each cell, that would be equal to base times height, which would be equal to 1.25 times 2.75. And what we would need to then do after we multiply that is we would have 1.25 times 2.75, and that would be equal to 3.4375 square inches. So we know that each of these takes up 3.4375 square inches. Now we know that there are 65,000 solar cells. So we know that the total area, total surface area, is going to be equal to 65,000 times 3.4375 square inches. So if we multiply that, we get 223,437.5, that would be square inches. Now the problem says we want to come up with the amount in square feet. So we would need to take these square inches and turn them into square feet. Now, in order to turn inches into feet, you would take the number of inches and divide them by 12. However, these are square inches, so you would need to square 12, which is 144. And to turn this amount of square inches into square feet, we would divide 223,437.5, divide that by 144, because 12 squared is 144. So to convert to square feet, you would take this and divide by 144, which would give you 1,500, and if we round, 52 square feet. So we have that many square feet, which answers the first question. Okay. Now, to answer the second question, which states the Helios are 18% efficient. Suppose they are only 12% efficient. How much more surface area would need to be covered to deliver the same amount of power? So what you need to take a look at here is you need to ask yourself, what would be the increase if we're at 12% and we need to cover the same amount as 8, or we need to make the same amount of energy as 8 if they're 18% efficient. The increase from 12% to 18% is a 50% increase. Okay, how do we know that? Well, because we know that 50% of 12 is 6, so it's a 6% increase to 18%. So we need to have 50%. We need to have a 50% increase in energy produced. Therefore, we need to have a 50% more square footage. So to figure out that, we would take 1,502. We would need to have 50% of that square footage added on, so we would divide by 2. And if we divide that by 2, we get approximately 776 more square feet. Again, the reason we divided by 2 is because we're being told that these power cells, these solar cells, are only 12% efficient. We need them to create the same amount of energy as an 18% efficient solar cell. So that is a 50% increase. Therefore, we need to increase our square footage by 50%. Now, the next problem says Harold works at a state park. He needs to seal the redwood deck at the information center to protect the wood. He measures the deck and finds that it is a kite with diagonals 40 feet and 70 feet. Each gallon of sealant covers 400 square feet, and the sealant needs to be applied every 6 months. How many gallon containers should he buy to protect the deck for the next 3 years? So first off, we would need to know the area of the deck. The deck is told to be a kite, and it tells us the lengths of the diagonals. We know that the equation to find the area of a diagonal is equal to 1/2 times the diagonal 1 times diagonal 2. So area of deck is equal to 1/2 times diagonal 1 times diagonal 2. We know the two diagonals are 40 and 70 feet, so we have 1/2 times 40 times 70. 1/2 times 40 times 70 is going to be, that's going to be 2,800. And then half of 2,800 is going to be 1,400. So we know that the square footage of the deck is 1,400 square feet. Now, that's not the question. The question is, how many gallon containers should he buy? So we know that it takes, each gallon of sealant covers 400 square feet. So to cover this deck one time, so to cover deck once, that'd be equal to 1,400 divided by 400, which gives us 3.5. So we know that to cover just this deck one time, we need 3.5 gallons. Now, he wants to buy enough sealant to cover to do this deck for the next 3 years. So it says that the sealant lasts for 6 months. So that means over the course of 3 years, he'll have each year he'll have to cover this deck 2 times, 2 applications, which gives us 6 applications each time, or for the total 3 years. So to figure out how many gallons you would need, you take 3.5 and multiply it by 6. So he would need 21 gallons of sealant. The next problem is, so this is a follow-up problem to number 6 on your homework. So number 6 is going to be, this would help you complete number 6 if you're struggling. You can sort of use this as a guide. It says, Doreen's family now wants to install 1-foot square terracotta tiles in the entryway and kitchen, and 4-inch square blue tiles on each bathroom floor. So it says the terracotta tiles cost $5 each, and the bathroom tiles cost 45 cents each. How many? So the first question is, how many of each kind will they need? The second question is, what will all the tiles cost? So to figure out how many tiles they'll need, we'll first need to look at the entryway and kitchen. So if we look at the entryway plus the kitchen, it creates a rectangle. So we need to find the area of this rectangle. We know that the base is 10 feet and that the total of the, so if we want to look at this height of this rectangle, would be equal to this distance of the living room and the dining room combined. So that gives us 13 plus 9, which is going to be 22. So we know that the sort of height of the kitchen is 22 feet. That tells us that the area for, we'll call it terracotta tiles, is equal to 22 times 10, which is equal to 220 square feet. Okay, so if we look at this, we have 220 square feet. Each of those terracotta tiles is 1 square foot. So the number of terracotta tiles is equal to 220 square feet divided by 1 square foot, which is equal to 220 tiles. So they need 220 tiles for those 2 rooms. Now we need to figure out the number of blue tiles for the bathroom, so each bathroom. So if we take a look at this, we have area of bathroom. So the area of the first bathroom is, again, is a rectangle, 10 by 6, so that's 60 square feet. And then if we look at the other bathroom, that is 7 by 9, that is plus another 63 square feet. So we have 60 plus 63, which is 123 square feet of bathroom. Now we would need to figure out how many tiles they need. So what we know is that each tile is equal to 4 inches square. Okay, so 4 square inches. So if we look at this, if each tile is 4 inches, we need to figure out how many tiles go in 1 square foot, because this is being measured in inches. So what we see is that we have, so 1 square foot would be a tile, or would be a space that is 1 foot by 1 foot, which is 12 inch by 12 inch. So 4 inches would break it up in 2/3. Okay, so what you see is that in each square foot there are 9 tiles, 9 blue tiles. So what we do is we take 123 square feet and we multiply that by, so number of blue tiles is equal to 123 times 9, which gives us 1,107 tiles. So they need 1,107 tiles. Now it tells us that each terracotta tile costs $5 and each bathroom tile costs 45 cents. So we have our cost is going to be equal to 220 times $5 plus 1,107 times 0.45. So our total cost would be 220 times 5 plus 1,107 times 0.45, which gives us $1,598.58 or 15 cents. $1,598.15. So that would be the cost of all the materials they need for those two areas. The final problem says the roof on Crystal's house is formed by two congruent trapezoids and two congruent isosceles triangles, as shown. She wants to put new wood shingles on her roof. Each shingle will cover 0.25 square foot of area. The shingles are 1 foot by 1 foot, but they overlap by 0.75 square foot. How many shingles should Crystal buy? So we need to figure out the total area that she needs to cover. So she has she has two trapezoids and two triangles. So the area of a trapezoid is equal to 1/2 times base 1 plus base 2 times the height. If we look at this picture, we see that the bases of the trapezoids are 20 and 30 times the height, which is 15. So we have 20 plus 30 is 50, half of 50 is 25, and we have 25 times 15, which is going to be 375. So 375 square feet. Now that is the area of one of the trapezoids. So we have two trapezoids, so we have to take 375 times 2, which gives us 750. So there's 750 square feet on the trapezoidal part of the roof. Then we have a triangle. So area of triangle is equal to 1/2 times base times height. The base of each triangle is 10, so we have 1/2 times 10 times 15. Half of 10 is 5. 5 times 15 is going to be 75. So we have 75 square feet, but that is only one of the triangles. There are two of them, so we have 75 times 2. 75 times 2 is going to be 150. So we have a total of 150 square feet on the triangular parts of the roof. So total area would be equal to 750 plus 150. So that would give us 900 square feet. To figure out how many shingles there are, we know that each shingle will cover 0.25 square feet. So we have 900 square feet times, divided by so we have 900 shingles or 900 square feet divided by 0.25 square feet, and that would give us a total of approximately 3,600 not tiles but shingles that they would need to cover this roof. So you're going to go ahead and work on your homework. If you have questions on them, message me on Remind or email me. You can ask me questions about them in class. But use these examples to help you work through the examples on the homework, and then I will see you in